Another aspect that we need to consider when we are mapping between our 3D space, right, and X, Y, Z, and on a surface of a triangle or some surface on some kind of mesh, and when we're trying to map a point in or the color of a particular point on our surface and trying to map it to the some color on some source image, right? The problem, one of the challenges is that we might run into what it's called aliasing. And aliasing is that we might end up undersampling the source image, right? That as we calculate these pixels on the surface of some 3D geometry, and then we calculate that corresponds to a particular point, right, on the image. We might be skipping or missing some information, right? That, for instance, these 3 pixels over here, although they might render next to each other on the screen, right? As we calculate and go back to the original image source, right? We calculate that this one maps to that one, and then this one maps to this one. Even though they might be rendering next to each other on the 3D space, on the source image, right? We might be missing the fact that in between these two, there's actually more information, right? That it should have been blue as opposed to white. And so even though we might be sampling the entire image, the resulting might be that it looks as if it were all white, right? And we're completely missing the fact that we have some striped colors in between, right? And so we are undersampling the source image, right? So and this happens because of the sizes, right, or the proportional sizes of how much information that we have in the source image and the size of the where we're mapping it to, right? When they differ considerably, right, where this area is much smaller than the image that we are grabbing, right? It could be that we're only looking at every other pixel, right, because we have fewer pixels to map to. So to deal with that, we're going to be very often going to be averaging out the colors of adjacent pixels, right? Where instead of looking at a specific pixel on the source image, we might be averaging out 4 or 8 or even 16 pixels in the image source, right? And then averaging out into a single color, right? So that if there's additional information around neighboring pixels of what that color might be, right, we can average it out, right, to then map it to the pixel onto that surface, right? So before we actually move it onto the frame buffer, for rendering. So yeah, averaging is going to be very important. We're going to be where you can choose whether you want to average out for every pixel. You want to average out all the surrounding 4 pixels around you, or 8 pixels, or 16 pixels. Usually a power of 2 of where you can average out all these pixels into a single value, right? And so if there's any information be around you, you're not missing out completely that information, and it makes it into the resulting image.